Hello, in this video I'm going to teach you how to write composition functions. So let's get a quick review of what function notation is to start. Function notation is where the y is equal to f of x. So let's just talk about f of x first. F is the name of the function. Sometimes we call it g of x, h of x, r of x, whatever. It's a letter that represents the name of the function. X is the input values to the function. So this could be f of 4, f of 7, f of another function, but that is what we're putting in to the f function. And then the y values are the output of the function. It's what we get after we evaluate the function with the given input. Let's look at a few examples. Here's a function named f of x. It is equal to 3x. So let's just break this down a little. The name of the function is function f. And here's what the function does. Whatever you put into the function gets multiplied by 3. So this is going to be input values times 3. So let's check out a couple examples. If we want to find f of 4, that means our input value is 4. It would be written like this. The f function with an input value of 4 is equal to, now let's make sure we understand what the function is doing. It's taking every input and multiplying it by 3. So we would just simply substitute 4 in the place of x. The input is 4 and it's being multiplied by 3. 3 times 4 is 12. Therefore, our input value was 4, our output value is 12. Let's do it again, where we're putting an expression in as the input. This says use the function f and input the term m plus 5. Use the function f, trade out the x for m plus 5, and remember, whatever the input is, we're going to multiply it by 3. So this time, we're going to multiply m plus 5 times 3. What we're really doing is just taking out the x and trading it out with whatever the input value is. In this example, we're going to have to distribute to simplify the function. 3 times m is 3m. 3 times 5 is positive 15. So the output is 3m plus 15. Let's see another function. This reads g of x is equal to x squared plus 1. That means the function's name is g. This is not g times x, we say g of x. Our input values are going to be squared and then added to 1. So what does the function do? Well, we're going to square the input and then add 1. Let's evaluate this function for 5. Our input value is going to be 5. So we're using the g function. We're inputting a 5. If we replace the x with the input value, the expression looks like this. Square the input, so square 5, and then add 1. 5 squared is 25. Add 1 makes 26. So our output is 26. Again, you can do this with expressions. This time our input is going to be 6y. So we use the g function. We're inputting 6y. That means where the x is, we're going to replace that with 6y. Now notice all of 6y is being squared, just like all of 5 was being squared. So you have to square 6 and square y. 6 squared is 36. Y squared is y squared. And then we add 1. This is a simplified function. These are not like terms, so we can't add them together. So the output is 36y squared plus 1. That hopefully is a little bit of a review for you about how to evaluate functions. Let's move on to how to compose functions. A composition of functions is just when you input one function into another function. When you're composing functions, the input value is a second function. The notation changes sometimes. Check out this notation. This is a pretty standard notation. It looks like the word fog, but really it's saying f of g of x. I prefer to rewrite this notation using this method. The f function with the input value of g of x. The g function becomes the input to the f function. If the letters are reversed, g of f of x, that's saying use the g function and input the f function. So the f function becomes the input to the g function. I know that's pretty confusing, so let's do an example. We're going to let the f function be 3x again, and the g function be x squared plus 1. Here we're to find f of g of x. First thing I'm going to do is rewrite that f function with g of x as the input. So the f function is 3x. I want to put the g function into the f function. So it would look like this. F of the g of x function is x squared plus 1. So now I can take the f function, which is 3 times the input, and my new input value is x squared plus 1. So just like above, we were replacing the x with whatever the input value is. In example 1, we replaced it with the number 4. In example 2, we replaced it with the expression m plus 5. In this example, we're replacing the x value with the g function x squared plus 1. Now, to simplify that function, I would just distribute the 3. 3 times x squared is 3x squared, and 3 times 1 is 3. So f of g of x would be equal to 3x squared plus 3. Let's reverse the composition. Here we're to find g of f of x. Rewrite that would be the g function, and the input value is the f of x function. F of x is the function 3x. So I'm taking the g function and I'm inputting 3x where the x was. So instead of x squared plus 1, the input value is now 3x. To simplify this function, I need to square the input first. So 3 squared is 9, x squared is x squared, and then add 1. This is already a simplified function. Therefore, g of f of x is equal to 9x squared plus 1. Okay, I'm going to end this video, and if you're ready to practice on your own, go for it. I'm going to create a series of videos to go along with the practice on the back of this sheet, so tune in if you need a little extra help.